polarization. In earlier video we discussed about polarization and reflection, polarization by reflection by Brewster law. We verified that. We discussed about Brewster's law also. Now we are going to discuss about polarization by double refraction. Double refraction means whenever the double refraction is happened when unpolarized light means natural light. We know that human eye can't distinguish the polarized and unpolarized light. So that's why here when the nature light means natural light is incident, unpolarized light is incident on the calcite crystal. When the natural light or unpolarized light is incident on the calcite crystal, then it will refracted into two rays. That one will be the ordinary ray, which is called as O ray, and another one is extraordinary ray, that is E ray. One is when the unpolarized light is incident on the calcite crystal, the light is split into two rays. One is ordinary ray, another one is E ray, means extraordinary ray. Ordinary ray, extraordinary ray, and at the end of the calcite crystal also it will be refracted. So here it is that in this case of the ordinary ray is having the same speed in all the directions. So that's why it will obey the laws of refraction in the double polarization by double refraction, because of it is having that when the ordinary ray is refracted in 2 points and which is obeys the laws of refraction, means when the light is traveling from the one media to another media, from rarer medium to denser medium, the light bends towards the normal, and whenever it is moving from the denser medium to the rarer medium, it moves away from the normal. So that's why it will be obeys the laws of refraction, ordinary ray. If in come for the extraordinary ray, this extraordinary ray does not obey the laws of refraction, because of here that the extraordinary ray having the speed, different speed in different directions in a medium. Whenever it is travels in a medium, then it has different speeds, different speed in a different direction. So that's why it does not obey the laws of refraction. Even though two rays are plane polarized, and those planes of vibrations are both are mutually perpendicular, means whenever it is traveling, it is vibrating ordinary ray like this in the plane, and this will be moves according to this, both are the mutually perpendicular. Ordinary ray and extraordinary ray both are mutually perpendicular. Based on this, to know this if the light is polarized or not, to know this, Malus has introduced an analyzer. First of all, Malus gave an idea whenever the light ray is traveling from the glass slab, then the reflected light is partially polarized. By taking that study, Brewster give an idea about that whenever the two rays, reflected and refracted rays, are perpendicular, then only the reflected ray linearly polarized. He give a theory about it. So that's why here, according to the Malus, when the unpolarized light, this is a unpolarized light is incident on the polarizer, and the light will be polarized. This is the plane of polarization, plane of polarized, and whenever it is incident, the sum of the angle made by the analyzer means if the light is polarized or not, to detect that is the light is polarized light or unpolarized light, the analyzer will be analyzed thus. So whenever it is making an angle, this is the perpendicular, the polarizer is perpendicular to the left, right, and whenever some of the angle made by the analyzer with the polarizer, then the theta be the angle. Then when a polarized light, when plane polarized light is incident on the, whenever the unpolarized light incident on the polarizer, and that will be polarized, it will move in this direction. In this direction only, already we discussed about it. And whenever the plane polarized light is incident on the analyzer, which is placed at an angle of theta, which is placed at an angle of theta with the polarizer, at an angle of theta with the polarizer. This is the polarizer and this is the analyzer, both are making an angle theta. Then the intensity of emerging light, the light is emerged, the intensity of emerging light from analyzer becomes I cos square theta, I cos square theta. Actually it becomes I theta is equal to E square cos square theta, because of E cos theta will be the angle B. E is the amplitude of the light, whatever the polarizer light is traveling from the polarizer and incident on the analyzer, then E square be the amplitude, but we know that is intensity is perpendicular to square is proportional to square of its amplitude. So that's why we can write that I is proportional to E square. So that's why we are writing that I theta is equal to I cos square theta. I cos square theta means this is a Malus law. This is a Malus law. I theta is equal to I cos square theta. Here the intensity of emerging light will changes by the changing the angle between the analyzer and polarizer. Means in zero intensity and maximum intensity can be found. Here if in case of theta is equal to 0 degrees, means cos theta, cos 0 is equal to, we know that cos 0 is equal to 1. So that's why we can get that whenever theta is equal to 0 degrees, then I theta is equal to, it is having I. If in case of 180 degrees also, it is I theta is equal to I. So the intensity is a maximum at theta is equal to 90 and 180 degrees. If in case of the angle between the polarizer and analyzer is theta is equal to 0 degrees and 180 degrees, then it is having maximum intensity. It is having maximum intensity means according to this polarizer and analyzer, if in case of both are having the same, the total polarized light travels into the analyzer. So that's why maximum intensity of light incident on the analyzer. If in case of 180 degrees also, the light will be plane polarized light will be travel through the analyzer. Then also here the intensity of incident light will be maximum. If in case of the perpendicular, means theta is equal to 90 degrees or 270 degrees, with that it is perpendicular line. So that's why here what will happen, it will be, means whenever the light is traveling like this, then if in case of it is perpendicularly traveling like this is the incident polarized light, plane polarized light. Whenever it is traveling, there is no light passing through the analyzer. So that's why here the theta is equal to 90 degrees, means perpendicular, which is having the perpendicular, which is making an angle 90 degrees. Then it will be, means the light is passing like this, but the analyzer is in like this. Then there is no light can be passed from through the analyzer. So the intensity will be 0. I theta is equal to 0, means theta is cos 90 is equal to 0. So that's why from the, according to the equation also we can get that theta is equal to 90 degrees, 270 degrees, that 0 intensity. Means according to this, the Malus law is when plane polarized light is incident on the analyzer, plane polarized light is incident on analyzer, which is placed at an angle of theta, which is placed at an angle of theta with the polarizer. The intensity of emerging light, the intensity of emerging light, the intensity of emerging light becomes I theta is equal to I cos square theta. That is I theta is equal to I cos square theta is the Malus law. This is about laws of polarization, means polarizing by reflection, polarizing by refraction, and also in case of scattering also we can find out the polarization by scattering. This is about Malus law. And the polarization by double refraction, means whenever the light is incident on the calcite crystal, it will split into the two rays. One is ordinary ray, another one is extraordinary ray. Ordinary ray is having the same speed in all directions, so that's why it obeys the laws of refraction. If in case of the second ray is extraordinary ray, that is having different speeds in different directions, so in a medium, so it does not obey the law of refraction. This is about wave optics polarization. Polaroids. After knowing about polarization by double refraction and Mahler's law and Brewster's law, polarization by reflection, now we are going to discuss about Polaroids. Polaroids are nothing but man-made polarizing materials are called Polaroids. Man-made polarizing materials are called Polaroids. Means when the synthetic dichroic crystals, when synthetic dichroic crystals are made, means by using the containing the synthetic, it's a thin transparent film. Man-made polarizing materials are, it's a thin transparent film. It's a thin transparent film containing synthetic dichroic crystals. Which is optical axis is parallel to each other, which is containing that synthetic dichroic crystals, which is having its optical axis is parallel to each other when the polyvinyl alcohol sheets are large strained. When the polyvinyl alcohol sheets are large strained, then the result, which is arrangement of the form of the molecules, will be long chain. When the polyvinyl alcohol large strained, the result which arrangement of molecules in like a long chain, and that sheets, the polyvinyl alcohol sheets are stained in ink which is contained the iodine, then the sheets will behave acts as a polarizing materials, that is called as a Polaroids. When synthetic dichroic crystals, it's a transparent thin film containing the synthetic dichroic crystals, when the polyvinyl alcohol sheets are large strained, the result of arrangement will be long chain, that is stained in the ink which contained the iodine. That sheets will act as a polarizing materials, that is the man-made polarizing materials are called Polaroids. The Polaroid sheets are used for both producing and analyzing the polarized light. To produce the polarized light and to analyze that polarized light, the Polaroid materials are, Polaroid sheets are, which is used. Once again, the man-made polarizing material is called as Polaroids when the synthetic dichroic crystals, it containing the synthetic dichroic crystals, then the polyvinyl alcohol sheets are large strained, then due to the strain the molecules are arranged in the form of a long chain, then that is stained in the ink containing the iodine, then that sheets will act as a polarizing sheets, means that is a man-made sheet. So that's why that material is called as a Polaroids. So here it is that the polarized sheets used for both producing and analyzing the polarized light. So what is the use of polarized materials? Means polarized lights are used to make the non-glare spectacles, means whenever we are using that, when the opposite light, whenever incident on our specs, the light will be glared. So due to reduce that, without non-glare spectacles, due to polarized materials, Polaroids are used to make non-glare spectacles and also 3D films and 3D pictures, as well as headlights of automobiles and side mirrors of automobiles, means wind screens and headlights of an automobiles, to reduce the intensity, to decrease the intensity of incoming light and glare. These are the uses of Polaroids to make the non-glare spectacles and in 3D films and pictures, and as well as the fitted to the headlights and wind screens. Fitted to the headlights and windscreens of automobiles are fitted to decrease intensity of light, incoming light, and glare of incoming light whenever incident on the eyes. Then it is also applied in the phenomena of polarization is used to make the LCDs, light emitting display crystals, means LCD screens, to make the LCD TVs like that LCD. In this case of the phenomena of polarization can be used, and to know the size and shape of the molecules by unpolarizing the scatter of light. Then by using this, the size and shape of the molecules and the helical structure of the nucleic acid also, by using the phenomena of polarization we can verify. These are about polarized.